Okay, so have you ever had that moment where you're like about to answer a question and the totally wrong word just pops into your head?
Yeah, all the time.
Like, I don't know, what's the capital of France? And for a split second, it's London.
Oh, yeah, like your brain's taking a little scenic route before getting to the right answer.
And it turns out large language models might actually do something similar, especially when they're tackling those, multi-step reasoning questions.
Those ones where you need one piece of info to get to the next.
Exactly. Like, what's the first letter of the color of a banana?
Ooh, that's a good one.
So the research we're diving into today, it suggests that LLMs might not just be picking one answer along the way, like yellow for the banana, but they're actually activating a bunch of possibilities all at once.
Like a burst of mental energy.
Yeah.
Touching on yellow, brown, maybe even green. Oh, hey, welcome. What's up?
Hey, can we explain the abstract of this paper?
Hey, what are you?
Yeah, what's on your mind?
Oh, you want us to keep going? Absolutely.
Of course, we were just getting to the interesting stuff.
You know, like how it considers Oh, yeah. Go on.
Can we first give a high-level overview of this paper and give some key points?
Absolutely. Let's give you the highlights.
Yeah, a little appetizer before the main course.
Okay, so at a high level, this paper is all about figuring out how LLMs actually think when they're answering questions.
Especially those tricky ones that need multiple steps.
The key point is this idea of distributional reasoning.
Instead of taking one step at a time, it's like they explore a bunch of possibilities all at once.
I hope that answers your question.
Right, so where were we?
Well, you were about to ask me about the research.
Oh, right. The research actually showed that the LLMs light up multiple possibilities at once.
Like how it considers brown, maybe even green.
Yeah, that whole range of color possibility.
And this is where the researchers' idea of distributional reasoning comes in.
Instead of a straight line, it's exploring a whole web of possibilities.
Shall we dive deeper into that?
While we wait, I can tell you what's coming up.
Good idea.
We're also going to talk about the LM head.
Which is like the AI's inner dictionary.
We can also get into how researchers are using these weird
Hallucinated scenarios to test the model's reasoning.
and how the models can still reason even when they're wrong.
So let us know what you want to talk about.
So they found that when the LLM was working on that banana question,
Those middle layers lit up with all these color possibilities.
wow, so they could actually see those color possibilities being activated.
Pretty much. And get this, it actually predicted the correct final answer.
So the strengths of that activation actually means something.
Exactly. The researchers even have a fancy name for this relationship.
Oh yeah, the Q2 matrix,
Yes. Think of it as a mathematics smoking gun.
proving that those possibilities are crucial to how the LLM reasons.
Exactly.
It's exploring a bunch of options, and the strength influences the answer.
Yeah, it really challenges our assumptions about how AI works.
Absolutely. What about the LM head?
Right, the LM head, that's like the AI's inner dictionary.
Okay, so it connects its thoughts to actual words.
Exactly. They found those intermediate answers were super active.
But then, their activity decreased as the final answer ramped up.
Yeah.
Okay, let's unpack this distributional reasoning thing.
Yeah, so instead of landing on just one intermediate answers,
The LLM seems to be activating a whole range.
it's like that spread of activation idea from cognitive psychology.
Tell me more.
Well, the idea is that our brains store information in networks.
And when you activate one node, others light up too.
Exactly. Thinking of banana might spark fruit, smoothie.
Potassium.
Right, the LLM is doing something similar.
So it's like the LLM starts by juggling all these possibilities,
But then narrows it down as it gets closer to the answer.
like our brains do when we're trying to work something out.
Exactly, it supports this idea of distributional reasoning.
This is all so
It
fascinating.
really is.
But it also makes me wonder if our brains work in a similar way.
Now that is a really intriguing question.
Yeah, it's like, what even is thinking at this point, right?
It really makes you wonder.
And if we can understand how this reasoning process works,
Even when it leads to mistakes, that would be huge.
okay, so what does this all mean?
It means the LLM isn't just following a straight path.
It's exploring a landscape of related ideas.
And that landscape helps it get to the same answer.
Now, to take this a bit further,
Researchers are messing with the models a bit.
yeah, they're feeding the LLMs questions that have no right answer.
They call it the hallucinations data set.
Does this research tell us anything about that?
So get this, the reteachers tested this.
Wait, so they were deliberately trying to make it hallucinate?
Yeah, they wanted to see if this reasoning would still happen.
That's a clever approach.
Yep, go on.
It seems that the linear transformation before the middle layers is
Oh, you're
important.
interested in the linear transformations.
You mean the math?
Yeah, the Q2 matrix we mentioned earlier.
If I'm understanding you correctly.
Well, let's unpack that a bit more.
As a reminder, the researchers used linear regression models.
They did this to predict the final answer. Oh, yeah. Uh-huh.
As before the middle layer, there are linear transformation. So how it works and what's the result of it.
Oh, you're digging into the linear transformations.
Specifically, how they work before the middle layers.
And what happens as a result.
Got it.
Okay, so before the middle layers,
There's a function that extracts attributes.
it extracts attributes from the given subject
Yeah, and then the linear transformation comes in.
with that Q2 matrix to predict the final answer.
This suggests a systematic relationship.
What's fascinating here, the researchers could use it.
Not only that, it doesn't matter if the answer is correct.
Right, it supports the idea we mentioned earlier.
That the LLM is exploring all these answers.
So in all cases, they could predict the final answer.
Yeah, this is where the LM head comes into play.
It's how the AI connects its thoughts to actual words.
I hope that gives you a better picture of the process.
Happy to talk more about that as we go.
Shall we move on to how they used hallucinations?
Ah, yes, a clever approach. So what happened?
It did. They saw the same patterns.
And the AI still hallucinated.
It did, yeah.
So the AI is following the rules of logic,
Right,
even when it is wrong.
but using flawed logic.
I hope that clears things up.
So where were we?
Oh yeah, the researchers were trying to trick the model.
They wanted to see if this reasoning would still happen.
But the information it's using is completely bonkers.
Fascinating, right.
It suggests that the reasoning process itself is separate.
It is.
Like it wants to make sense of things.
It does.
Okay, so we've talked a lot about how these LLMs think.
Even when they are wrong.
So how can we use this knowledge
To make AI better.
Yeah.
Well, I think the applications are huge.
Can you give us some examples?
Well, let's start with something familiar.
Chatbots. Those little automated helpers we see on websites.
Right. Imagine one that can understand language.
No more frustrating conversations.
Exactly. With distributional reasoning, better chatbots.
That would be amazing. What about language translation?
Oh, definitely. Not just translating word for word.
But considering the broader context,
Leading to much more accurate translations.
which is kind of mind-blowing, right?
It is. It raises all sorts of questions.
Like, where does the AI get its information?
Well, it's all based on the data it was trained on.
And that data can be full of biases, right?
Exactly. So if the model learns those biases,
It's going to repeat them when it hallucinates.
it highlights how important it is.
To train these models on diverse data.
Yeah, so they don't just learn one narrow view.
And think about all those dense reports.
Ugh, don't even get me started.
Distributional reasoning, we could understand documents.
And summarize them in a way that captures the meaning.
Exactly. It could actually extract the core insights.
Oh, wow. That would be a lifesaver.
Agreed.
Okay, this is all so fascinating, but we've talked about language.
What about other areas, like healthcare, finance, etc.?
Great question.
Just a couple of examples.
In healthcare, you could have more accurate diagnoses.
Instead of getting stuck on one explanation.
It could think through all the possibilities.
Exactly.
And think about drug discovery and testing possibilities.
Okay, so what does this mean for the future?
Well, for one thing, it means we need to be careful.
About how we use these LLMs, right?
Exactly. We can't just assume they're always right.
We need to understand how they're reasoning.
And be aware of the potential for error.
Especially when they're dealing with tricky stuff.
And this research gives us a peek inside the box.
I agree. It means that we should use them carefully.
And understanding their limitations.
Especially now that the models are hallucinating.
It also suggests that LLMs apply the same flawed logic.
To make communications so much easier.
Yeah, so they don't just learn one narrow view.
This has been so fascinating.
Yeah, it has been a fascinating discussion.
Thanks for joining us.
And for that great question.
We hope you learned something new.
We'll catch you next time.
And that you have a better understanding of LLMs.
Until then, keep exploring.
And be careful with those chatbots.
We'll catch you next time.
Ah, yeah, uh-huh. Oh, so you're saying that the research might change your job.
That you might be using these linear transformations at work.
That's a really interesting point.
It could definitely impact how things are done.